Hi, I'm Eugenie Brichkov, and today we will go through the process of the design and assembly of the serial interface board for the MSX computer. For quite some time I was looking to build something useful, exciting, and learn something new. My friend Eric Boyes told me some time ago that he is building an appliance using serial interface boards, but he is short of these interface boards. And I decided, why not build classical RS-232 interface to connect MSX computer to the PC and transfer data over the channel. Having got Sony HBI 232 service manual from Eric, I decided to use it as a source.
Original cartridge is a rather big device, with significant portion of the glue logic in it. I would say that initially I was not impressed by its electronic design regarding open collector chip select circuitry. However, after close consideration I changed my mind and now think that design is almost optimal regarding minimization of the glue logic on the board.
My first action was just to redraw the original circuit diagram. It was very good exercise in terms of understanding how a board works and how should I expect firmware to work with board's hardware. I didn't have a cartridge, and I asked Eric to supply me with the high-resolution photos of the original board and found out that board's manual contained error in the frequency of the clock crystal. Eric proposed eliminating glue logic here, and there, putting a kind of Gale chip instead. Some time ago, I was helping Fabrice Farlet getting his custom MSX computer running on the Altera's Max 7K chip, and decided to use such 44 CPLD chip for my device. The endeavor was not easy as I was learning classical CPLD technology in parallel. First, I had to find out which pins are input only, which are dedicated to JTAG programming in order to connect them properly from the start and minimize reworking at later stages. At the end, I was short on pins with Max 7K and had to put one extra glue logic chip onto the board. If I would disable JTAG programming, I would have enough pins. However, after reading feedback about issues with programming with JTAG port disabled, I decided not doing it. Another change I introduced is removal of terminal modem switch and making DB9 connector modem only version. If user will want to connect terminal, let him just use non-modem cable. And last goal I set was to fit the design into standard Konami-sized cartridge board.
The project requires usage of various tools. For circuit and board design I used Eagle from Catsoft. For CPLD configuration design I used Quartos from Altera. To view and check Gerber files I used application called GerbV.
The main task at the beginning of the project was to understand how a device works and if I will be able to source components for its manufacture. The serial port can be accessed through ports and through memory space, and port accessibility is controlled by a flip-flop. The beautiful open collector design saves at least 2 glue logic chips. Then we have memory related to the operation of the device, ROM part and RAM part, with RAM residing inside the ROM addressing area. Then there are 2 core chips which do the job, USART 8251 chip timed by the timer 8253 chip. In the receiver transmitter circuit to the right, you see a set of ferrite beds. Unfortunately, a manual doesn't show which nominal they have, and I took 600 ohms at 100 MHz analog SMD ferrite beds instead. They are required in order to suppress high frequency noise which may confuse receivers. Note that in the final design I decided not to put ferrite beds onto protected ground to minimize probability of the grounding problem between serial port devices, which potentially can damage them. Then here we see some resistors, capacitors and semiconductors connected to the ring indicator input line. Why is this? For a very simple reason. The set of receivers contain only 4 elements, but here we need 5, and this circuit represents a kind of internal of the MC1489 receiver. The status read is built on IC12. This IC is also used to generate interrupt request, which will be used by the machine to flush data which is ready from the device. You can see that firmware may have interrupts enabled or disabled. After power on, interrupts are disabled, and also port access is disabled. The last part is clock generator. Its output frequency is 1.8432 MHz. Note that in this circuit, IC16B device is required in order to ensure square-like waveform of the clock generation output at increase in its output capacity. Now we'll look at what I have got after modification of the original schematic. Almost all the glue logic was put into the CPLD, and I replaced generator with crystal generator of required frequency. I wrote board manually. This one was uneasy, but I did it. Here you can see JTAG connector I introduced, and this small piece is an adapter board to connect standard Byte Blaster plug. I am familiar with Quartus and Verilog, but Fabrice shown me another way to create configurations in Quartus using schematic design. First I drew glue logic, then attached them to input and output pins, and then assigned pins on a schematic to physical pins on the chip using pin planner. I must say that I had to replan layout several times in order to get optimal board design.
After completing all this, I had board manufacturing files, CPLD configuration file, and a list of required components on hand.
The mandatory exercise before I sent files for board manufacturing was to source all components and check their footprint with the board design printed in 1:1 scale. This way I found out that footprint for the JTAG connector I use, which I built using connectors datasheet, is not the best for manual soldering, and I had to correct them increasing length of the pads. I also finally ensured that no components overlap each other and I can easily solder them, and in which sequence should I do it.
So, we are now ready for assembly. We have necessary tools. We have necessary components. And we have PCBs. I always make 2 PCBs in case one will fail, or I will fail assembly of one of them. So, at this point we have board manufactured. Nice one. The hardest task was to solder PLCC socket. So what we're missing now? We're missing two things. First one is ROM chip. We need to program ROM chip. I have two of them. And we need to download configuration to Altera CPLD. We will do it now. I have nice programmer here, and we will now load the ROM image into the chip. Excellent, it's done. And now we're going to download configuration into the Max 7K chip. I have this great PC. This is Yamaha MSX PC, which I use as a power supply for the board to program, because Byte Blaster is powered from this side, not from this side. I have my own Byte Blaster connected at the rear of the PC, and now I'm going to download configuration. Let's turn on the power supply. Go to the programmer and program the chip. Successful. Great. Now we are ready to test board on machine. What do we have now? We have PC with serial port, we have MSX computer with big monitor. Let's try the board. Before inserting the board and before connecting it to PC or to anything else, I prefer to power off MSX and to unplug it from the receptacle. I also have a cable. This is very old serial cable which I made 20 years ago. It works with my programmer. It has only 4 lines connected, and let's see if it will work. Putting board inside, connecting one side, connecting another side, another end of the cable. Okay, what we do now? Now we power on MSX. Well, it starts, it's good news. Let me make color so that it's visible. PC has does already have a hyper terminal running on it. So I know that by default the card works in 1200 baud rate, and I've already set up here in the hyper terminal. So let's type anything. Works, great. Then type call com.ini. Great, it doesn't give any error. Now there is a magic command, COM-term. It is a terminal through COM port. Call COM-term. Excellent. And I will try typing anything on the PC. Hello, I am MSX. Haha, it works. Some kind of buggy, but it works. Now let me type something here. Hello, I am PC. So, what we have here? Hello, I'm MSX. Excellent. And on the PC, what do we see on PC? Hello, I'm PC. Excellent. So, we can conclude that it works. Probably it needs some more debugging, because we can see here are some strange symbols. Probably it happens because a cable only has 4 lines, but the board expects more lines. We will see. I will troubleshoot further, and I will see if I can write any program which will be able to send files through the RS-232 interface to the MSX. So, I would say that what we've done was successful, and thank you very much for watching this video. I hope it adds some value to you. Thank you, bye.